Let me very quickly introduce myself and AxonIQ, just a few minutes. So my name is Frans van Buul. I'm officially known at our company as not the sales guy, as it says on my mug, which kind of means that I am responsible for sales in some sense and telling the world about our products. But I'm a developer as well. I spend about half of my time doing Java coding and the rest of the time telling the world about what we do. So AxonIQ is a new company, started in July of this year, so just a few months ago. And the core of AxonIQ is Axon Framework. So Axon Framework is an open source framework that by itself is not new, has been around for about 5 years. And the reason for starting this new company around it is that its adoption is increasing rapidly. The download chart that we get from Maven Central is exponential. Last month, about 50K downloads. And the main reason why it's becoming so popular now is that people have kind of rediscovered some of the principles behind Axon Framework in the context of microservices, but we will be talking a lot more about that later. So the business model from AxonIQ is to provide services around Axon Framework, consulting, training, that kind of stuff. And we provide a number of commercial software products in addition to the open source. That's all I wanted to say about the company. This talk will just be about the open source stuff that we do, so that basically has not that much to do with the company. Agenda for today, first thing I want to do is to go over typical layered architecture phenomena, the problems associated with those, some stuff about DDD, and how that relates to microservices. And after that I want to jump into CQRS and event sourcing, and how these concepts are implemented in Axon Framework. And then finally I will show you some code examples just to give you a flavor of what it looks like to work with Axon Framework. Let's start by considering the layered architecture. Very familiar picture, I guess. Everybody has implemented this a ton of times. So you have a number of layers. The main ordering principle is that the dependencies only go one way, and then they have this shared language that we call the domain model. Sometimes there may actually be business logic in the domain model, but more often than not, those are just very anemic, logic-free data holders that are really processed by the service layer. Now let's zoom into that domain model a little bit. Domain models start simple in the beginning of the project, and then they evolve as you add more classes to them. And to make that concrete, let's have a look at your typical Webshop example. Everybody knows that. You can place orders. Orders have a number of order lines. Order lines relate to a particular product and refer to a quantity of that product that you're ordering. Products have a price. Order lines a quantity. Quantity times price added over all the order lines gives you the value of the total order. Simple, will work. Now, if you have a web shop, then it's not just about orders, it's also about maintaining the list of products that people can buy, right? It has like a set of product categories, so it's a product catalog perspective. Now, interesting thing happens if prices change. Prices will change, go up in the web shop. Now, in this model, once you start updating that price, what will happen is that you will also modify already existing orders, which is not what you want because they have been ordered at a particular price point. So this model very quickly brings you into trouble. So you need to solve that. And one way of doing it, I'm not recommending it, but one way of doing it would be to say, well, actually products have multiple prices because there's an historical evolution of the price of those products. Each order line refers to a product and a historical version of that price. And then my products, of course, also have a current price, the price that I'm currently displaying in my store, which might work, but is spectacularly complex for something that seems so easy, right? It's a very simple use case. So if this simple use case already brings you logically into this kind of mess, what happens if your program really starts to evolve is that you end up with something like this, also known as the big ball of mud. And my colleague Allard always says that's the architect sitting on top. Now, interestingly, if we go back to this picture, we've seen the complexity in this domain model. But the main thing that we're doing here in this model to manage complexity is to use those layers. But those layers fundamentally have nothing to do with the complexity. So you can add layers all you want, but adding more layers is not going to solve the problem because the problem is not in the layers. It's as easy as that. Now, this is, I think, is where microservices have a very interesting role to play because they are a fundamentally different approach to managing the complexity. Instead of managing complexity by having layers, you say, I'm going to manage complexity by breaking my system up into very small units that by themselves don't carry that much complexity. So it's an attractive idea. And if you are there, you can also scale them separately and deploy them in all kinds of different ways, upgrade them separately. So it's a good proposition. But there's some interesting stuff going on with microservices projects. These are some quotes from Martin Fowler. And he says, well, many successful microservices projects have started as a monolith that was then broken up into microservices later on. But on the other hand, if you start out with a microservices architecture because it's such a great pattern, chances are that your project will fail. So what should you do? You should actually start with that monolith and then break it up. But at the same time, this is more like a quote from myself, having heard from many people, is that it's really difficult to do that. If you have this legacy monolith, there's no easy way to split it up into microservices. So what you'd like to do ideally is start simple and then evolve that, but avoid the big ball of mud scenario and instead go to this structured monolith that you then later on can split into microservices or even more microservices as needed. So this thing, that's what we call the Big Friendly Monolith. It's a monolith, but it's a monolith that's manageable and that can easily be split up into microservices as needed. So this is the kind of thing that we want to support with Axon Framework and that many of our users actually have successfully done. And we have some case studies on that scenario in our booth as well. So what is Axon Framework? Open source framework, started out as an open source framework for CQRS in Java, and the CQRS principle is something we will discuss in more detail, and it's actually the thing that will make this evolutionary microservices possible. The essential parts of the framework is that it's messaging oriented, so you have components that message to one another, and we recognize 3 different types of messages, events, commands, and queries, and not just events, and that's a very important part of it. It enables location transparency, so components don't really care where other components are, and that's the thing that makes it easy to split up an existing application, and it's highly customizable. So you can start out by using very simple technology if you have this monolith. You don't need fancy message buses or anything. But then later on, if you want to integrate it with Kafka or Rabbit or whatever, that's also possible without changing the business code. The core pattern behind it is CQRS, command, query, responsibility, segregation. And as the name suggests, that means that you have separated your application in 2 sides, one handling commands, one handling queries. Commands are things that change state, so it's a request to do something, but they don't provide any information back. Maybe a confirmation that they have been executed, but that's it, no more information. Queries are exactly the opposite. There are questions, you get answers from them, but they don't change the state. They leave the state unchanged. This side of it is called a command model. Those sides are called a read model, or projections is a term you would often find in the literature about this. Now, of course, this can only work if the projections are up to date with the state of the command model, which means that there's a third component here, and those are the events. So whenever commands lead to a change in the command model, they will raise an event. The event will be picked up by the projections, and then you get good answers from your next queries. So this is a pretty complex thing to do, right? If you compare it to having just one model and processing that for transactions and for queries, this introduces a huge amount of complexity. So a very good question you could ask is, why would you do this? Well, there are many technical reasons. One of them is, for instance, that the throughput characteristics may be totally different on those 2 sides. If we consider again the Webshop example, then changes in your product catalog happen quite infrequently compared to the number of times that this product catalog is actually being accessed by consumers. So you may wish to optimize for those 2 things in a very different way. And if you optimize your right side for processing transactions, you would probably normalize them. And that might lead to very complex queries on your read side to actually produce that data again, which will be bad for performance. So there are many different technical reasons, but the overarching reason why you would want to do this is simplification in the long run. So if you look at a very simple application in the beginning, it introduces some additional complexity because you have those commands, those events and everything. But in the long run, you will find that these individual command handlers and event handlers are simple objects that are easy to maintain and expand. Zooming in a little bit on those two sides, this would be the command model. A very important aspect of the command model is that you start thinking in aggregates. So aggregates are like units of consistency and persistence. You split up the command model in a number of different aggregates where you stop having connections between everything. If you do a typical data modeling thing in a database, you might have foreign key relations between all objects, making it one big thing. Where you think in aggregates, you use smaller units. And to make that concrete here, if we go back to this order and catalog example, we might have an order aggregate that has a number of order lines, which carry a price and everything. And then separately from that, you might have a product aggregate, which has the category and the current price. So what happens now is that when you place a new order, this aggregate gets created. It records the price at that point. This product aggregate is being updated when the price changes in the web shop. But this would not directly affect an existing order. So you have to solve your problem of modeling in a lot more elegant way. Looking at the read side, key thing here is that you have many different read models segregated. Typically, it might be one per use case or one per screen in your application, just optimized to very efficiently, very simply deliver the data needed for that particular use case. You may also use very different technologies there. In a Webshop example, again, you might want to have a full text search on your product for people to find what they need. So you may use an elastic search engine, for instance, behind that. Other stuff may better fit in a relational database model. Other stuff may fit better in a document store. But this concept of CQRS and read models makes it very easy to implement those various technologies alongside each other without your application architecture becoming one big mess. So if we put those things together, this is kind of like the Axon architecture. You would have command handling components that have their own storage model, domain model. If something changes there, they would publish events. Those get picked up by event handling components. They do updates on a separate storage, and that's where you would do reads. Of course, the application user interface connects with both parts of that, so it's still just one application from an end user perspective. Looking at that again as a sequence diagram, the product manager would create products that would raise an event, like a product created event. That would end up in the product projection. So that's when it becomes available for shoppers, would show up. The consumer would do a get product info query, get that info, including the price, and then the product would be added to an order, which would end up in the order projection. So that's the kind of logic that you would have in this model. Now, one thing where you have a choice in this model is how to persist aggregates. So these aggregates are persisted in the command model, and they're being read back, of course, whenever a new command needs to be processed. Now, the traditional way of doing that would be just to persist the current state into a database. And in Java, many people would use JPA. Other approaches are possible as well, of course. But it's always the current state. Now, there's one interesting alternative that you might use there, which is used, in fact, by most Axon framework users, although it's not mandatory, but it's very popular. And that's event sourcing. So with event sourcing, you don't store the current state. But what you do instead is store all the events that have happened that would change the state. And then whenever you need to read back this aggregate, you would just replay all those events. Which again seems like some complexity. And there is some performance hit, of course, as well. But there are some great benefits in doing that. And the benefits fall into two categories. There are some business benefits, and those are the most important ones, motivating organizations to do this. And those are, there's a lot of value in capturing all that history. That may be value for compliance purposes. If you ever need to show exactly what happened in a particular case. For instance, we have some online casinos that use Axon framework, and for them it's very important that if a dispute arises, that they can show exactly what happened, and they're using event sourcing for that reason. And the other reason is more into machine learning and analytics and data science. It's about exploiting the simple fact that data is valuable. It's very valuable to know what happened and to optimize your business for that. Just to show you an example, suppose again that we have this web shop and it sells fruit. Then you could order 2 bananas and 1 peach, and that would be just the order aggregate. But in an event-sourced world, you might actually see that something else has happened. So the apples were added to an order, and then apples were removed, and a peach was added before the order was actually committed. Now, this is for order fulfillment. The apples are totally irrelevant because they were not ordered. But from a business optimization perspective, it's very interesting to learn that I was on the brink of buying apples and then decided not to. So what could the shop do differently to make me buy those apples next time? Right? That's an interesting thing. So you don't want to forget about that, and that's what event sourcing gets you. Another reason to do event sourcing is that it's interesting to capture intent. So suppose I have a customer database, and I'm updating the address with a simple update statement. It will work, but it will not show any information as to why that address was updated. In an event-sourced system, what you would do is create events that specify what happened, and they would have as a result that in read models the address get updated. But you may distinguish between a mere correction of an address versus an actual customer relocating to a new address, which are from a business perspective different things that you might react to differently. If you get the second event, you might send a nice postcard to your customer saying congratulations on your new house. It doesn't make any sense if it's the first event. So it's good to make that distinction. That's what event sourcing can do. So the CQRS stuff and potentially event sourcing are really interesting ingredient to this Big Friendly Monolith, because already in the concept you're splitting off things. These aggregates, they have small boundaries. So different aggregates can really easily live in different microservices. The read models are separate. You have read models per screen or per use case. Read models don't have to coincide with the command models on the same server. They just have to be able to exchange events. So there's a very natural mapping between this concept and microservices. There's just one other thing that you will also need, and that's location transparency. If those various components assume that they're all on the same server, then you cannot get into microservices. If they always have to communicate via a bus or something, then you're kind of in this place where where you're starting with microservices from the beginning. So you want to abstract that away and allow evolution in that dimension. So the way we do that in Axon is that all communications between those components, they take place through a bus API, so just a set of Java classes. Components do not make any assumptions where other components are. And then in the Axon configuration, you can either choose a very simple implementation of those buses that just lives inside a JVM and passes all messages directly, or you can choose an implementation which actually goes over the network and goes to different systems. Now, importantly, in our messaging concept and our bus concept, it's not just about events. We see that sometimes that these architectures are being proposed where that are so-called event-driven and then all components just speak to one another in the language of events. We believe that this is not a very good idea. Reason being that events lead to a particular dependency between components. So in this example, we have a component A and a component B. Component A raises an event that's being processed by component B and potentially also by other components, of course. And this creates a dependency from component B to component A because component A determines what this event looks like. They're raising the event. And B has to adopt itself to the model that A has created. Now, if events also flow in the other direction, from B to A, then the same mechanism ensures that there is a dependency from A to B. So the two things are now interdependent. You have the cyclic dependency, And the chances are that if you need to change something, you need to change both components, which is exactly what you do not want to do in a microservices architecture. One of the benefits should be that you can update them separately. Now consider what happens if you use commands as well. If A sends a command to B, then A has to adopt itself to the command language that B has defined. It's a client, so it's dependency from A to B. And then if events are being sent back from B to A, that's again a dependency from A to B, because A has to adopt itself to the events produced by B. So the dependency is now only in one direction, and you can't change A without making any change in B. That's a fundamentally better place to be. So this is one very important reason why we believe it's not just about events. The other thing is that if you look at these three concepts, commands, events, and queries, they have quite different routing patterns. So command always has to be processed once, and you need some confirmation that this has happened. Ideally, you want some consistent routing. If you have many instances of command processors, it's a good thing to send commands that are targeting the same aggregate to the same instance, because then their caches will be warm and it will work a lot faster. Events is a totally different routing thing. So events are being spread to everyone. You don't get any confirmations on them. But it's very important with events that they're being processed in the right order. Suppose that you're writing this read model and you get an order created event and then an item added to order event, but you have multiple instances of the read model and the order created event is being handled by one of them and the item added to order will be added by another instance. Doesn't work. If the order of the events doesn't match anymore, because first you get the item added to order before the order was created, some things will not work smoothly either. So they have some specific event routing requirements. And then queries are again different. So usually you have one query handler giving an answer to a query, but there are some cases where you have scatter-gather type of patterns or competing queries. Think, for instance, about a pricing service where you put a second pricing service next to it for special promotions or Christmas actions through discounts and everything. Then your logic may be with queries that you want the best, which is the lowest answer to your price query. So there are some specific routing patterns possible with each of those things. That's again a reason why we believe these kind of architectures should not just be about events. Messaging is richer than that. Let's have a look at a few examples, and let's have a look at the time as well. So if you use this style of architecture, of course you need to define a lot of commands and events as classes, and they all tend to be immutable, very boring to write. So even though you can write them in Java directly, almost nobody does that. It's quite popular to use Project Lombok for that, where you can annotate your classes and then generate a lot of the stuff that you need to create those immutable classes automatically. But it's even more popular nowadays to use Kotlin for that. So even if you don't use Kotlin for your entire Axon project, it may be very useful to use it just to define those data classes. You can define many of them just in a single file. You can just declare all the variables that you need, and then you will get a bunch of immutable classes with equals and getters and everything and constructors. So that's the most popular thing to do. Another thing that maybe that's relevant to note about this example is that here in this add order line command, we're using this annotation target aggregate identifier. So that's the thing that helps Axon to know which aggregate you're targeting with your command. It's not needed when you are creating a new aggregate, because then it doesn't have an ID yet. But of course, if you need to add an order line to an existing order, you need to specify which order it should be processed in. So the flow would be that if this command is being processed by Axon, it would start reading all the events related to that existing order, replay them, then you have the state of that order in memory, and then you can actually execute a command. So that's how it would work. Sending commands in the client would usually look like this. So you have this command gateway object, which is your entry point into Axon. Based on input you get from the user, you would set up one of those commands. Here, create new order command. We choose an ID for that. Most of the time, people use UUIDs because they can be generated without any concerns about uniqueness, etc. And then it's being sent through the command gateway. So that's where Axon will pick it up. And dependent on the configuration, that may mean that it's actually being handled in the same runtime, the same JVM, or it may go over the network, but this code wouldn't know about that at all. Inside the aggregate, your code may look like this. So you have, of course, an aggregate identifier that you need to annotate, so Axon knows what you mean with that. And then there will be command handlers and event handlers. Command handlers do a bunch of checks, so they will determine whether or not the command is allowed to be processed, but they will never ever change state directly, because change will always go through events. So what they will do if they decide that everything is okay, they will call the apply method, which is a static method in Axon framework, and include all the information in the apply method that's needed to update the aggregate. Actual updates will be done inside an event handler. So the order line added event may be used here to change the state of the aggregate. Now, what's interesting and a little bit counterintuitive is that you don't need to store all state in the aggregate. The only reason why you would store state in an aggregate is if you somehow need that state to make command decisions later on. If you just want to remember it for querying it, to show that data to users, you don't need to have it in an aggregate. Because that will be done by the read models. And the read models will get a chance to process these events as well. So in this case, the only business logic implemented here is that we validate the quantity on a command, cannot be less than 1, but nothing else is being validated. And if that's truly my business logic, then I wouldn't need to store anything in my aggregate. You could even drop this event handler altogether. Now suppose that I have a little bit more complex business logic, and we would check here that the total order value can never be bigger than 10K. Then, of course, you need to start maintaining some state. And to maintain that state, to do that check, the only thing that you would need to remember is the total value of the order. And that would then be updated here in the handler. But there's no need to store all the order lines, for instance. Of course, this is just to illustrate the principle. If you would work this out in a little bit more detail, probably that would be a good reason to keep those order lines here. But it's important to know that you don't have to store all information in the aggregate. The read models would look like this. You would have an event handler there as well. And basically how you do the rest is up to you. So Axon in its current form doesn't do a lot for that. This is an example with JPA, but it could be any type of technology. The core thing here is that you're capturing those events and then updating your read model accordingly. Something that will be included in the new version of Axon, that will come out in a couple of weeks, is that queries will be handled over a bus as well. Currently, queries would just be direct invocations of, in this case, the final orders method. And we don't have a way to easily put those on the bus or create location transparency for queries as such, but that will be included in the new version. Now, so far we've seen how to program with Axon, like in your domain model side, and your command handling side. Of course, you also need to set up that infrastructure. Now, assuming you're using Spring Boot, and you just want to have a local command bus and a local event bus, and use event sourcing and use all the defaults, then there's essentially nothing to configure. You can use the Spring Boot Axon starter, and it will just work, and all these examples will just run. Now, once you start to evolve, if you go over that journey into microservices, you are going to change those things. Now, one of the simplest changes that you could do is go to an asynchronous command bus. So the default thing that you would get without configuring anything is a simple command bus. Now, if you're using Spring, then you could define an alternative command bus bean that would be the asynchronous command bus, and that's sufficient to get all your commands being processed asynchronously. If you want to actually distribute it, there are various options. One option is to use JGroups. What you need to do to enable that is to put the right dependencies in your project, so they're on the class path, and then enable one configuration property, and then it's a distributed command bus. So that's very easy to do. So without making any changes to your application logic, you can evolve from a monolith into microservices. You can also use Spring Cloud. That's a little bit more complex to configure, and I won't go into all the details. It's the same concept. Create some additional bean factory methods, and you're in business. The examples that I use are all in Spring. Most Axon framework users use Spring, but it's not tied to Spring. You can use it without as well. So to summarize, we believe that this concept of CQRS and potentially event sourcing and DDD are really important ingredients into having these evolutionary microservices, and helps you to get started quickly but don't end up in the big ball of mud scenario. Apart from that evolutionary aspect, event sourcing has some really interesting benefits because of keeping history, exploring the value of data and compliance. So that's a valuable concept by itself. And Axon Framework is a really easy way to implement this in Java. You don't have to use it. Honestly, there's no magic there. You could do everything that Axon Framework does yourself. It's just that it's a waste of your time because it's already there and it's free. If you're interested and want to learn more about this, we will have some Q&A, of course. We will, Marlijne and I will also be at the booth. Marlijne has a lot more Axon experience actually than me, so please ask us anything. If you want, you can also register for our mailing list, and then we will send you some updates occasionally. It's very, we would very much love for you to do that. We have about 50,000 downloads a month, and we only know personally a couple of hundred Axon Framework users. So it's very important for us to get a lot more connections into the Axon Framework community. So that's why it's so valuable for us. Thanks a lot.
Thank you very much. I got a bunch of questions. We have some time left, so I'll try to ask most of them, and otherwise the booth is just outside this room, so that helps. Can you elaborate on how to guarantee consistency? Do you query the read model in the write model? Do you use compensation events instead? How to start simple but allow room for improvements?
Okay. So in this architecture, consistency requirements are usually relaxed, so you have eventual consistency. You don't have consistency at every point in time. You can get that if you want to. You could use a synchronous event bus and command bus, and then you can actually process everything in a single database transaction, and then we would have guaranteed consistency. But the problem with consistency over an entire system like this is that it doesn't scale well. You cannot really move to various microservices and then do big database transactions on all of them. So the key strategy is to use eventual consistency and simply accept the fact that your business model will not be consistent on every millisecond. That's how it's usually dealt with.
What do you think about having chatty commands in the context of building REST APIs, returning newly created resource, for example?
So the thing that is directly supported by our command handling is that it returns the ID of a newly created object, but only the ID. Now that may or may not be enough for your users. If it's not enough, the way that we recommend you would do it is to create a synchronization layer on top of your actual command and read models. So you would first create something, and then read it back from the read side of it, and then give that result back to your users, but still keep the same architecture pattern in the back end.
This question might relate a bit to a previous one. How do you guarantee events delivery? Is there a way to resynchronize the models?
Yeah, so there are multiple ways of handling events. One would be to just listen to new events coming in and then acting directly upon them. Another thing is what we call a tracking event processor, which means that events would get stored in an event store, which can be a database or something else. And then these tracking event processors would read from the database and keep track of where they are, hence the name. If they are not online for a while, they could just start reading again when they come online and continue on the last place they have been. And also, if you create new read models, you would need to read back all old events to initialize that read model. And this can also be done with those tracking event processors. So the basic way of guaranteeing that events don't get lost is storing them, essentially.
And how do you deal with potential time delays between a command? No, yeah. See the right one? Yeah, sorry. Excuse me. How do you deal with potential time delays between a command executing and being able to read the data from the query model?
So first of all, you should evaluate whether that's a real problem. Sometimes it is, sometimes it's not. In many cases, it's totally acceptable that it will take a few milliseconds before your read model gets updated. If it's not, there are a few solutions that you could do. One of them, the simplest one, not very elegant, is simply wait. And the other thing that's needed, when you have a more stringent requirement here, is that you include some kind of timestamp with your command. And this timestamp would then be replicated by the read model as well. So you can get a query to the read model saying, I want to read as soon as you have processed this timestamp. That's one way of doing it. It's kind of evolved, so that's not the default thing you should always do, but it's a mechanism that will work and is sometimes used.
One that's pretty relevant with GDPR coming on. For event sourcing, how do you handle the fact that you may need to delete some data, for example, for privacy reasons, which may lead to inconsistency?
So did we pay someone for that question, or did we pay someone for that question?
No, I don't think so.
Funny thing is that what I told in the beginning that we have a number of commercial software products on top of the open source, and one of those products is exactly designed to deal with this issue. So the issue is that if on a GDPR you have to erase data sometimes, if people ask that, and events are immutable, so it's hard to erase data from events. Now, one way of dealing with that is exploiting the fact that events are conceptually immutable, but physically just data, so you can actually change them, which goes against the model, but it will work. But there are some big disadvantages there. It's kind of hard to do. It diminishes the value of your event stream as an audit log for compliance reasons. So one other thing you can do is use cryptographic erasure. So you could encrypt personal data fields and then store the key somewhere else, not in the event stream, but on a separate key database. And then you could throw away that key if you get a request to erasure, and that will make the personal data fields effectively erased because you only have them in an encrypted form and you cannot decrypt it anymore. So that's what you could implement that yourself, but we have implemented our GDPR module on top of Axon to enable this specific scenario.
Can you elaborate on potential downside experience using event sourcing?
It's a good question. What do you think about that?
I think it is applicable for a lot of applications, but I have to say, yeah, one downside might be that your database is getting really big, and that's what customers might experience. Of course, there's another commercial product, an event store, but yeah, that's for really big sets of data, but that might be, but for the rest of it, I think it's pretty useful.
Yeah, that's actually a pretty good point. So if these event stores, they tend to grow, and relational databases don't really like having tables with billions of records. So as long as you are producing 1,000 events per day or 10,000 per day, it's a total non-issue. But some of our users are producing 10,000 events per second. And then these tables grow very fast, and there are some managing issues there. Yeah.
And of course, if you have applications that are that simple that you don't need all the events or not going to use the events, then you should not apply event sourcing. It's not like perfect for every application, but most applications would fit. Yeah. Is it possible to migrate existing historized data, not event stores, to an event source in retrospect? If yes, how?
So yes, the only thing that you cannot do is suddenly discover history that you haven't persisted in the past. Of course, it's not magic, but you can migrate. What you would probably do is create a special set of events that represent the migration, and then replay your old store into these new events, and then ensure that your event handlers can deal with normal business events as well as these migration events. That just works.
Can you compare Axon to other CQRS-based frameworks for creating microservices like Lagom?
Honestly, I can't. I'm aware of Lagom, of course, but I don't know a lot about the details. If I talk to people not using Axon or that have used Axon but went to something else, it's usually Akka. So people move to Scala, Akka, and I think that's closely related to the Lagom stuff. And that's honestly just a different abstraction. So they use an actor abstraction. We use commands, queries, events. And if you want to do CQRS on top of that, it's just a lot more involved. That's all I really can say about it.
Is there built-in monitoring tool for the message bus in Axon?
No, there is not, but there will be. That's, again, one of those commercial products that we're developing.
Who did you pay?
Yeah, it's, if you look at the entire roadmap of what we're doing, then of course we will continue to evolve the framework itself. And one of the things in there being better support for queries, query location abstraction. And the other things we're developing is an event store for processing super large numbers of events, and a new routing platform. So you can do all the routing that's needed for commands and events and messages with traditional technology like Rabbit or Kafka or whatever you want. And that works. But to implement those more advanced messaging routing use cases, it kind of gets involved. It's not that easy to do. So we're developing this new messaging platform, which will allow you to do that very easily, and also give you better monitoring capabilities.
I think that's the questions from the app. Do anyone else has a question, as we still have time? Thank you very much.
Thank you.